Welcome, everybody. We're excited for another Sawtooth Software webinar. Today, we're going to talk about conjoint analysis, and we're going to have Brian McEwan with us. Before I introduce him, I have a few items of business, but excited to have everybody join. We've had a great turnout for this, and we are excited to hear from Brian. Just a little plug here for Sawtooth Software. We are working on a really exciting tool called Discover. And Discover is really good at conjoint analysis, also max diff, and it can just do general interviewing. So regular select questions and quota control and skip logic. We are excited about this tool and we continue to improve it every day. So you can try Discover for free at discover.sawtoothsoftware.com. We encourage you to check it out. Also, on the next slide here, I want to make sure that each of you know that we have an exciting webinar coming up on March 28th at 1 p.m. Eastern, and you can register on our website. This is with Sinu, who is a conjoint analysis legend, one of the originals who came up with conjoint analysis, a professor at Stanford. We're going to have a sit-down kind of interview with him, and I encourage you all to check that out. Okay, so excited to announce our speaker, Brian McEwan. He and I have worked together for many years. He has been at Sawtooth Software for over 15 years, and he's worked really helping people understand teaching conjoint analysis. He loves to do this, and he's really good at it, and he's also a really nice guy. So Brian McEwan, if you could turn on your camera and take it from here, we're excited to hear from you.
Thanks, Justin. Justin's a pretty nice guy too. So I'm pretty excited for today. Like Justin said, I think this is one of my favorite parts of my job at Sawtooth is I get to talk to a lot of people about what conjoint is and how does it work and why is it so neat. So we put together this webinar to try to take that kind of introductory pathway. So we're going to talk about an introduction, dabble a little bit in the history of what conjoint analysis is. Then we'll talk a little bit more about how you actually do it. How do we create our questions and build the exercise for respondents. We'll talk about what do we do once we get the answers from our respondents. And then we'll talk about maybe some slightly famous case studies, usages of conjoint analysis that you might not have been aware of, and then do some questions and answer. So when you think about preferences, how people feel and value about things, it's pretty common to take a product and break it down into its smaller parts. So if I wanted to know how someone felt about a can of Diet Coke, it's pretty defensible that I could say their feeling about this thing is probably made up of how they feel about Coca-Cola in general. How do they feel about it being a sugar-free Diet Coke version? How do they feel about it being in an aluminum can? And then there's probably a price involved. How does that affect things? And so this idea of thinking that a product is kind of the sum of its smaller parts, that's really the mindset that we're in when we're talking about conjoint analysis. A synonym would be conjoined, right? That things are put together, they're related or made up by two or more things. That would be our dictionary definition of conjoint. And that's how we're going to be thinking. That's our world in conjoint, is that a product or service or experience is made up of smaller parts. And I'm not sure why, but ever since I started, my mind thinks about Lego blocks. I've always loved Legos when I was a kid. My kids have all my Legos. And this example has just what's always come to my mind when I think about describing this. You have Legos and you take Lego blocks together and you build something out of them. And any one Lego block with the basics here are swappable with other ones, and you can build different things with them. So if I was going to build some Legos and then put together, I've got a turtle here and maybe a dinosaur Might look like a giraffe. I'm going to call it a dinosaur. If I were to take these two options and go to one of my kids and say, "Hey, look at these things I built. Which one do you think is better? Which one do you like better?" Um, I might start thinking about these things as a sum of smaller pieces. So the one on the left is made up of green and yellow Legos. Maybe it's a little medium size, it's a little larger, it's a turtle. The one on the right is made up of red and purple blocks. It's a smaller size and it's a dinosaur. And my son might say, "Oh, I like the dinosaur better." And I think to myself, okay, that's interesting. I wonder what was it about that resulted in that choice? Was it the colors? Was it the animal? Was it the size? What is it that's driving that choice? Additionally, I might change things up. I might find some eyes and put them on the turtle, and all of a sudden, now that we have a turtle with eyes and a dinosaur without eyes, that preference changes, and the turtle is a lot more attractive. And I might think to myself, well, what was it? Was the turtle and the dinosaur close together and the eyes just kind of tip the scales a little bit? Or the eyes hilarious? He just thinks that's the best thing ever. And that drastically shifted the preference. Maybe I start thinking about what would happen if the dinosaur was green and yellow, or what would happen if the turtle was made up of more mixtures of colors or something like that. And then, again, this is the type of thinking we're in with conjoint analysis. What is it about these things that make someone like it a little more, a lot more? That's really the questions that we're trying to answer. So that's our question of the day. How can we know the value of these parts, whether it's a Lego block or it's a can of Coke or it's some sort of bundled telecommunications product where you're buying internet and cell phone and cable TV and things like that? How can we know how people value the smaller parts that make up that option? So, a common approach to doing this is to ask people directly and say, let me think about the features. How important is the brand familiarity? How important is calorie content when you're choosing a beverage? Or I might ask people, here's different brands or here's different flavors of Coca-Cola, rate them on a scale of 1 to 5. That's pretty common, and people would be able to give me answers. It's maybe slightly challenging to think about, is something extremely important or very important, but generally speaking, people can do these. Sometimes they don't work out as well as we'd like. Sometimes we're only asking about important things and everyone tells us that everything is important. But these rating scales have a lot of problems. Often there's a lack of discrimination, so people can say everything's important, and there's no forced what's first, what's second, or anything like that. There's kind of inherent problems with scale uses. Some people float at the top. Some people maybe are a little grumpier on average and float at the bottom. Some people use the full scale. Some people don't. Um, People in the US use a scale differently than someone in Germany or Japan, for example. There's also really tough issues if you're trying to not just get the number, but do something with the number. There's a thing called the halo effect, where if people, for example, really like your brand, they're going to rate it high on all the factors related to that product, even though they might actually not be as good. There's this haloing effect. There's reliability issues. Would people give the same ratings the same way? Are we interpreting the scale correctly? And then again, if you want to do something with this, it's hard to make that jump from a scale answer to like a behavior. If something is a 4, does that mean someone buys it? Does it have to be a 5? How do we use that information? So there's lots of evidence out there that trying to build preference models based on these type of importance rating scales, they just don't seem to work very well. So we like this idea of a product being broken down into its smaller parts, That's a very rational and defensible idea, but rating scales historically don't do a great job at helping us understand what the total preference is and what does that translate into, for example, purchasing behavior. Additionally, directly asking people questions can be really, really hard. Unless you were recently shopping for laptops. If I asked you, well, how much would you be willing to pay to go from a 500 gig hard drive to a terabyte hard drive for your next laptop? I could not give a good answer to that right now in the moment. How much battery life would I sacrifice to fully charge my phone battery in 30 minutes? Gosh, I don't even know how long it takes my phone to charge because I just plug it in overnight and then I wake up in the morning and it's full and it sits on a little dock right here most of the day. How much would I be willing to pay for a particular food certification that something was sustainably caught or harvest, or that something was certified vegan or something like that? It's a really tough question to answer in a vacuum without some sort of context for it. So directly asking people, it's challenging. And so to overcome a lot of these problems, that's really where we get into the history of conjoint analysis. Um, the one of the first papers came out in 1971 by Paul Green. He's kind of considered the father of conjoint analysis. There was another one later in the 70s by Sinu, who Justin mentioned. We're excited to have him for a sit down. And this original type of conjoint, what this was something maybe a little different than what we commonly do today. The original conjoint approaches were something like this, where we might have a deck of cards and we would ask people to sort them best to worst. And what that initial research found is that even though you're asking people ordinal data, you're just saying this is better than this, and by default, you kind of have equidistant, right? Rank one, rank two, rank three. You can actually get metric data. We can build a model that has distance, even though we didn't ask for distance. We can calculate a distance by having people sort numerous things that are carefully designed. The other earlier form of conjoint analysis used scales. So you might do something like this, where you show people one option at a time and you say, on a scale of 0 to 100, where 100 means definitely would purchase and 0 means definitely would not purchase, how likely would you be to purchase this option? And you do the same thing. You show them repeated offerings where we're varying them and we're trying to understand what's the relationship between what's shown and the answer that we get. Now, the other thing that these early research papers talked about was how important it is to choose the right questions. So this is kind of a visual representation of those 9 options back there. And you can see, for example, that we show 30 yard, 40 yard, 50 yard an equal number of times. We have 3 30 yards, we have 3 40 yards, we have 3 50 yards. And we also are carefully controlling these so that if we look at our 3 30-yard options, one of them holds 16 people, one of them holds 12 people, one of them holds 20 people. One of them is at the high price, one of them is at the medium price, one of them is at the low price. So these early building blocks were setting the stage for this conjoint type of thinking, where rather than ask people directly about things, I can show them a realistic concept, carefully construct a handful of them, and then derive the benefit from them. Okay. We're not going to get into too much math today, but as you can see, I really like visual examples. They really help me understand things. So most people are pretty comfortable with thinking back to a high school math class, a situation like this where you might say, I've got temperature here and I've got ice cream sales. And I can see that there's a relationship. As the temperature increases, my ice cream sales go up. There's a relationship here. And we can do some math and we can figure out a way to fit a line in there. And we can generalize that relationship. We could eventually come up with a point where we say, for every X increase in temperature, ice cream sales goes up by Y. We can generalize that relationship, even though we don't have a particular data point for every single temperature. We can generalize that relationship, build a formula that can help us estimate what would happen outside of the data collection points that we had. Okay, so this would help us answer if I want to estimate how does the change in temperature affect the demand for my ice cream sales in this example. Okay, so we think back to that our skybox example, right? If we're only thinking about one thing at a time, it's reasonable that we could show people the same skybox and say, how does their rating scale change as the price goes up, right? Basically the same thing. How does the preference that would be our y-axis, and the cost would be our x-axis, and we're trying to figure out, for example, for every x increase in price, how much does that change someone's preference for it? And so with conjoint, we're just doing that with multiple variables. Same idea. Don't worry too much about it, but it's the same type of a thing. I'm just changing more than one thing at a time and then evaluating how does that preference change. Okay. Now, at the same time, as Paul Green and Sinu Srinivasan were working, Rich Johnson, pictured here on the left, that was Rich was Sawtooth Software's founder. He was working on similar problems to try to, again, quantify how do people trade off things? How do we come up with valuations? And Rich did some work in trade-off analysis and also came up with these paired comparison approaches. Same idea, as we change the configurations, how does that affect the scale usage of strongly prefer left, strongly prefer right? So this is another variation of conjoint analysis, a paired comparison approach. Around a similar time, there's a guy named Dan McFadden who worked on the choice approach to this type of preference data. If I show people different, for example, transportation options, is there a way I could, for example, nudge people to take the bus more often rather than drive their car? Dan actually won the Nobel Prize for economics for his work in coming up with the theories and the modeling specifics for analyzing this type of discrete choice data. So rather than scales, we're just asking someone, here's a couple things, make a choice. And then that leads us to Jordan Louvier on the right here. He provided a really robust basis for most of the conjoint analysis work today with his paper, Design Analysis of Simulated Consumer Choice or Allocation Experiments. So we're moving from scales into choices here. We have an example here of 3 different vacation packages, trying to figure out what's desirable and what preference someone might have for their next vacation. Now it's a good time to talk about names a little bit. Shakespeare wrote, "A rose by any other name would smell as sweet." So conjoint analysis was the name given to those rating scale type approaches, and discrete choice was used to describe the choice approach. Now, when marketing and academic people familiar with conjoint saw the discrete choice work, it was kind of a natural extension to say, oh, I get what you're doing. It's the same type of a thing. I have attributes of my product and different levels that they take on, and I'm building profiles, and I'm just asking people to choose rather than give them a score, for example. And so that's why, depending on your background, you might hear discrete choice a little more often. But in the, for example, marketing world, it's maybe a little more common to hear choice-based conjoint analysis. It's a different variation. Now, some people have very strong opinions about those names. at Sawtooth Software, we're pretty easygoing. Use whichever one you like, but that's a common point of confusion for people coming in is depending on the world that you're in, you might see these things called different names. And just remember the overall world that we're in is showing people full profiles, real product options, and then asking them for some sort of answer, whether it's a choice or a scale or a rank. It's kind of all in the same family of things that we're doing, right? The goal is to say, how do people feel about these different parts of things? And ideally turn that into a purchase. At what point, how good does something have to be for someone to choose it or purchase it in the real world? Now, some additional definitions. Um, we're going to stick with choice-based conjoint, discrete choice. Moving forward, it's by far the most popular method these days, and you can kind of see why. It replicates the real world better. It's more realistic. It's a bit more natural. People see multiple things and make a choice. We don't walk down the grocery store and give things scores out of 100 very often. So we typically say this would be a conjoint task or a question. They're made up of multiple concepts. So this example, we have three concepts here: Toyota, Tesla, and a Kia. Different cars with different. These are electric vehicles. They have different ranges. On our left, we have the attributes. So these are our Lego building blocks. We have brand, the type of car, the range, the warranty, and the price. So we call those levels. So the attributes are the building blocks, and the levels are the different variations that each of those attributes would take on. In the choice-based world, it's often very common that we also show a fixed option. It's typically called the none choice, and it represents kind of I don't like any of these things. It's the opt out, or it's the status quo. We could change that text to say, I would stick with my current car for another year, or I would figure out something else, or I'm not interested in electric vehicles at this time. So it's a very common add-on for choice-based exercises like this. Now, thinking back to our ice cream example, it doesn't work if we only get a single data point. If we only had a single line, we could draw that line any way we wanted, and it would be unhelpful. So the only way to build that relationship is to get multiple data points. So in a conjoint experiment, someone is going to see a handful of questions. It's very common to ask, for example, a dozen questions. So we get those repeated measures, so we can show people lots of different vehicles at high prices and low prices, and large range and low range, and high warranties and low warranties. And that helps build up. You can kind of think of it like a scaffolding. If we want to understand where Toyota stands relative to the other brands, we don't just want to show one Toyota. We want to show a lot of Toyotas. And we don't want to show Toyotas always really expensive or always very cheap. If we want to understand, is the preference for Toyota driving someone's actions, then we need to show it at high price points and middle price points and low price points and high ranges and low ranges. And that way we can tell if someone keeps choosing Toyota, we know, that's their preference. They have a strong high preference for that brand. So respondents will go through and see multiple varying questions. The set of questions that people will see is typically known as the experimental design. And similar to scientific experiments, we're trying to control things. We're trying to see if I apply some sort of treatment, if I make the car cheap or I make the car expensive, then what happens? What's my outcome? So we use terms like experiments and designs because it's the same type of thinking that you would use maybe in a healthcare trial. Good experimental designs, like I mentioned, will ensure a fair experiment. It would be unfair if we showed lots of Toyotas and only a couple Kias. It would be unfair if we showed Kias with really low prices all the time. Um, Now, one thing to keep in mind is that conjoint analysis is not concept testing. So a lot of people would say, well, hey, a Kia is less expensive than a Tesla on average. So shouldn't it be more realistic to show Kias at lower prices? Now, the answer to that is maybe. It depends. Um, with conjoint work, there's not a lot of set truths, only one way to do something. There are ways that we could build our design so that Kia would show up at lower prices on average. And that might add a little bit of realism. But if you remember, our goal here is to build the generalized model. So if I really want to understand and kind of isolate and pinpoint how someone feels about Kia, I do a better job at that when I let everything be balanced and fair. Okay. We could represent an experimental design like this. So we have there's question one. We show three of these experimentally designed options. And then we have that none choice that's kind of the static fixed option. And then we have question two, and we build an additional set so that across all of these questions, if we were to go down to the bottom and do a count if, we should see every one of these levels showing an equal number of times, ideally. We don't have to be perfect in practice, but that's always our goal. Okay. And so, again, I already mentioned this, our skybox, even back to that original card sorting conjoint. This is the driving principle behind why conjoint works so well, is to be very careful and make sure all of your options are nice and balanced. So if I wanted to test my Legos with my children, I would need to put googly eyes on all the options and sometimes not have googly eyes. I want to make turtles that are red and dinosaurs that are green and yellow. I want to show lots of variations in a fair and balanced way to try to figure out what is it that's driving that choice. Now, that might seem really complicated, um, and it is kind of hard. It would be very difficult to do in person. These days, we use software and algorithms to do that for us. So I'm going to show you a quick example here. We're going to build a quick survey, and there's really not anything I need to do. So this is Discover. Justin mentioned this is our online platform here. We think it's pretty great. We think it's pretty easy to use. Like Justin said, it does general survey questions and grids and open ends and ranking questions and things like that. We're going to add a choice-based conjoint exercise here. I'm not going to build a whole survey. I've got one sitting at the ready. I just wanted to show, generally speaking, how the process works. So I've got an example. If I was wanting to know where we should all go out to eat the next time that we're all together, and so I want to do this in a robust scientific way. So I can use a conjoint to do that, where I think about what are the features, what are the characteristics of where we're going to go. And I might do, well, cuisine is the first one. And there's Mexican food, there's Chinese food, there's American food, there's Thai food, and I might come up with a couple different options for that. I might think about the proximity, and I might say it's a 5-minute walk, it's a 10-minute walk, maybe it's a 10-minute by bus or car, something like that. I might think about the average Google review. Maybe that's something that affects people's preferences, and we might test a 3.9 stars, 4.2 stars, and 4.5 star is our average review. Now this part is always the hardest part of any conjoint experiment is deciding what your attributes and levels could be. A lot of times there are probably we could come up with a huge list that would just overwhelm our respondents. So there's no fixed rules. A lot of the times, we could throw out some numbers like, hey, it's probably good to keep your attributes and levels to maybe like 7 or less. Um, as you become more experienced with conjoint, you'll start thinking about it depends a lot more. There's things we could do. We could have a longer exercise. We could have a larger sample size, um, et cetera, et cetera. We've tried to distill a lot of that experience into Discover to try to make some recommendations for you. So right now, Discover is recommending that I show 3 options per page and ask 9 choice questions. And that will vary as the number of attributes and levels go up, it's going to suggest larger numbers. I do have some control. I can override this and I can say, I'm a little worried about respondent fatigue or something like that, and maybe change things a little. So we give you a nice recommendation, but there's it's definitely a spectrum. You can think about kind of a safe range for things. So I've already gone ahead and built this just to avoid the time here. I'm going to go ahead and give us a minute. I'm going to put this link to this survey into the chat here. If you're interested, let's go ahead and take the survey. We'll give everyone a minute here. I'll go ahead and take it myself. We'll pause for a minute, and then a little bit later, we'll look at the results. Actually, I think I posted that just to the other panelists. Justin, are you able to post that into the general chat for everyone?
I think it is in the general chat. I don't know if a panelist can confirm. It says that you posted it to, yeah, let me try. Everyone. Okay. Sorry, guys. Here it is. Everyone should have it now, and they can start clicking on the link that you see in the chat and then take the survey.
We have just a couple segmentation questions. We'll see if perhaps there's any correlation between age and conjoint experience to food preferences.
Hey, Brian, I have a little question for you, if you wouldn't mind.
Yeah.
Someone asks, Julian asks, could Discover be a replacement for Lighthouse Studio? How would you answer that?
It's a good question. So Lighthouse Studio has been around for a long time. It's obviously had a lot of years of development. We do a lot of fancy stuff in Lighthouse. Discover is a younger product. It is fantastic at doing these type of conjoint experiments, but conjoint is a pretty big rabbit hole to get down. I mentioned, for example, there's ways to make the pricing change depending on the configuration of the product. Um, Doing a lot of fancier things like that usually would send you into Lighthouse Studio, our desktop product. So Discover is not going to replace Lighthouse anytime soon. We definitely want to take all the goodies, all the things we've learned over the years that we've added to Lighthouse and bring them into Discover. So that's the long-term plan is we're going to take all those goodies, all those fancy advanced things, and bring them in. Right now, we only do a handful of those fancy advanced things into Discover. So Discover is absolutely the best option if you're a beginner. It holds your hand a bit more. It's a bit more automated. It's kind of on autopilot for a lot of things. So it's a fantastic option if you see yourself only doing a couple projects here and there. But if you're, a consulting firm where Conjoint's going to be a big part of your business, you'll probably outgrow Discover and hit some complicated projects that require some of the flexibility that Lighthouse offers. So they both kind of right now they occupy kind of different spaces. They're both fantastic options, and you've got arguably the best support team in software. I'm a little biased, but I think you'll definitely find success with either one.
I am going to post a link in the chat that shows the differences between Lighthouse Studio and Discover. I'll do that a little bit later.
All right. So I'm done here. If you're still taking the survey, that's totally fine. We're going to keep going on. I'll come back to these a little bit later, and we'll hopefully have some numbers that show us some interesting things. So let's talk a little bit about the numbers, analysis and outputs. So what are the things, and this again speaks to the robustness of having a strong set of questions where it's an even playing field, everything is balanced. We could do something very, very simple and just look at the counts of what people choose, right? So because each of my food options is going to show equally with big distance and low distance and high reviews and low reviews, um, as we get lots of choice tasks from lots of different people, we could just look at the counts, and this would be meaningful. It would be meaningful for us to say, hey, Mexican food at 20% got chosen a little bit more than twice as often as the fish and chips option. And then the American option was twice as preferred as the Mexican option. And those are valid insights, right? That reflects an average preference for the group because we had a nice balanced playing field across all of these questions that everyone answered. However, what counts does not do is put us into this conjoint world where we're saying, I'm really trying to get to a valuation of how each small part contributes to that overall choice. So counts kind of gets us there a little bit, but isn't really this model to say an option, a dining choice, is made up of small parts. And some of those might be good, some of those might be bad. That's really what we're trying to get to. So it's typical to estimate what we call utilities. And the word utility is really grounded in economic theory. Utility refers to the satisfaction or the value that someone derives from consuming a good, using a service, engaging a particular behavior. We're talking about the good that something provides. And utility theory kind of forms the basis for analyzing consumer behavior. If you've gone through the Econ 101 class, they talk about the rational man. We build these models of behavior, assuming that someone has self-interest and they're utility maximizing. They're making decisions to bring that good to them. Back to our temperature ice cream sales, that's essentially what we are trying to come up with. How much higher are my ice cream sales as my temperature goes up? How much more that delicious vanilla cold ice cream, it increases in utility. It becomes a more desirable thing as the temperature around me goes up, right? So we're trying to quantify the utility. How much better does ice cream become the hotter and hotter it gets? Okay. Or in my skybox example, how much utility, how much better does an option get the closer it gets to the 50-yard line? Or how many, as the number of Lego blocks increase in a package, how much does that increase the likelihood that I'd say, yes, I will purchase that option? Okay. So when we run this analysis, whether it's scale-based or choice-based, that's what we're doing. We're trying to come up with utility. We're trying to put numbers to those preferences that are usually very hard to get from people directly. So that's really the one of the best parts about Conjoint is we're not asking about a bunch of things in a vacuum on a 5-point scale. We're asking people more natural, realistic questions, and then we're decomposing, we're breaking it down afterwards to try to figure out what preferences would explain the choices I got. So, for example, if this was one respondent's utilities, a very high positive utility on the fish and chips, that would come from fish and chips being chosen over and over again. So even when it was a further walk, even when it was more expensive or maybe had lower reviews, it still provides a lot of positive utility just by virtue of being a fish and chips option. And in this respondent's case, the type of cuisine is a bigger impact than, for example, the price. So the swing between a good option and a bad option on the cuisine shifts my total utility a lot more than going from the low price to the high price. Okay. Um, Again, just some definitions. Regression models are typically what we use to estimate these utilities. We could use linear regression for our scale-based. We use logistic regression when we do choices that are bounded by 0 and 1. You might come across the term hierarchical Bayes. That's kind of a framework for running a regression where we have a hierarchy. We have the top level is kind of an aggregate model that explains everyone's choices. And then the lower part of the hierarchy is a set of utilities for each individual person. And we use some Bayesian statistics to kind of think about someone comes from the group that looks like this, but also made these individual choices. And so we kind of balance out that information of what does everyone look like and what did this one individual do. So you might come across those terms as you're learning more and more about conjoint analysis. I mentioned the shift, the spread in utility. We can actually quantify that, and we typically do, and we call that importance. So we, in my example here, if I look at the difference between the highest and lowest level of cuisine, I get a shift of 129.2. And if I look at my shift in utility for my price, I get a 32.6. So if we just pretended for a second here that these were the only two attributes, I would say this respondent has a total amount of variation of 161.8, and the cuisine accounts for 80% of that variation I see. And so we would say cuisine has an importance of 80%, and the price has an importance of 20%. It's kind of their impact into the variation of the model. And we use that as a proxy for summarizing the relationship between our attributes. So utilities are very common. They make great graphs. People love to put them in PowerPoints, and it shows what was happening. We love, most people love importance scores. They, again, just help us summarize what's going on. But those things are both looking back. So utilities and importance, they look back. They say, why did the respondents give us the answers they did in the survey? But the really cool part, and this is the best part about conjoint, is that utilities can be used to look forward and make a prediction about future decisions. Okay, we call this simulations. They're usually called running a market simulator. And what we can do is, since we've taken we've decomposed all of the levels of our product. Well, we've talked about our starting point is to say Coke plus Diet Coke plus can plus price. Now that we have all the building blocks, we can swap those blocks out and build concepts and then make a prediction of which one is the rational man utility maximizing choice for someone. So back to my Legos. So I build one Lego figure here. It's Mexican. It's a 10-minute drive. It has a slightly lower review and a slightly higher cost. There's some total amount of utility that represents. And I build another one here. It's American, 10-minute drive, slightly higher review. And so each one of these pieces is adding more utility. And for every respondent, I can look and say, what's the building blocks? What's the total utility here? And I can make a choice prediction. And so we can do this for every respondent, even if I didn't specifically ask you about a $9.99, 4.2 review, 10-minute drive American Place, because I built that carefully constructed design and built the generalized model. I can now make a prediction that's based on robust data of how you would feel about this one particular configuration versus the other particular configuration. So market simulators let us make share predictions. We can build different options, and then for every respondent, we can say, which one do we think you would choose, and come up with these share predictions. So we could look here and say, on this sample, about half, a little more than half the respondents would say the American option is their most preferred, and about 24% would say a fish and chips would be their most preferred. And then, of course, we could run these over and over again. We could hold everything constant, and we could just change, for example, the price of the American option. And we could look at this price sensitivity. We could build a demand curve and say, as the price of the average main at the American Place goes up, we see a drop in share. So these are typically called sensitivity simulations to build our demand curves. So simulations are absolutely the best part about Conjoint. They don't have any of the baggage of utilities and importances and things. It's just down to we are making predictions of what people would do. All right, we're almost out of time. Oh, I'm going to go back. Let's go back really quick and look at our utilities here. Okay. Fish and chips not doing so hot on average in the group. Now, interesting, I'm sure there's individuals where fish and chips is their most preferred option. And that's another benefit of conjoint analysis is we do this for every single person. So we could go through and find people, maybe look for characteristics of people who had a really positive utility for fish and chips. We're pretty rational. We prefer longer walks. We're rational. We prefer lower prices. We prefer higher average ratings. And it looks like the distance was just slightly the most important thing, which is kind of interesting. I when I took the survey and just looked at my results, I had the same thing. I really like the idea of taking a 5 or 10-minute walk. I don't love the idea of getting into a car and parking and things like that. So that's pretty interesting. Looks like we had 139 people take the survey. Thank you so much for that. And we can run some simulations. So if I was looking at what's nearby, I can build some options here. And we'll put fish and chips in here, but we're going to make it really good. We're going to make it cheap with really high ratings and see what happens. Make this fish and chips. Okay. So this goes back to that balancing act, the building blocks. Even though fish and chips on average was the least preferred option, if I push the scale up, I give it the larger Lego blocks, I make it really attractive. then it can be the top choice for a large number of people. Um, so hopefully you can catch a vision for using the simulator to answer strategic questions for what features should a product have, what the price should be, and just that freedom to be able to test and retest and evaluate the shift in demand for your product. It's a lot of fun. We're almost out of time. I'm not going to go through all my examples. I'm going to hit a couple here just so you're aware. I won't read through all these. Courtyard by Marriott was designed originally to target high frequency business travelers and lower frequency leisure travelers. And they did lots of conjoint exercises on various parts of the hotel to design the room and to design the amenities and things like that. And it's been a wildly successful brand. Conjoint was used in the Samsung Apple patent trial to try to quantify demand and valuations and maybe how much Apple's demand for their products was hurt by similar designs and things. That one's really interesting. The Portland Trailblazers used Conjoint to revitalize their multi-game ticket options to try to figure out they could mix low demand games with high demand games against teams that had star players. And they found that really low cost things like free food provided a lot of utility people instead of expensive things and doing free jerseys and things. We will send out these slides. You can read through these again. I want to make sure we have a little bit of time for Q&A. So I'm going to go ahead and wrap up there. I hope that was interesting. I'm guessing we probably have some questions to go through.
Yeah, there's a ton of questions, lots of activity. I appreciate Aaron and Cameron for jumping on and helping us with these. Before we go to live Q&A with Brian, just want to remind you of Discover. We're really excited about it. Check it out at discover.sawtoothsoftware.com. And then reminding you about this webinar coming up with Sinu that, Brian, if you could advance the slide, that we'll be having coming up on the 28th. So that should be a great webinar. Thanks, Brian. Excellent job as always. And Brian, if you want to start looking through the Q&A, answer some of them live, and then we'll stick around and answer all of them through chat for sure.
Sure. All right. So the first question I see is how many attributes shall we use? And that is the $1,000,000 question. Obviously, the more stuff you put on a page, the harder the question becomes. But you don't necessarily want to not include something that might be important. So I'll say one thing is that conjoint is probably not the first thing you do. There's probably going to be some initial research about maybe some qualitative stuff. Maybe you do a focus group, you talk to people, you figure out what type of attributes come up in the conversation. Then I also mentioned there are design approaches in order to handle a larger number of attributes. If I am showing all of them at the same time, I'm probably going to throw out a number like 6, 7, 8. I'm sure there's lots of people both within my company and outside it that would probably argue slightly differently. So there's not an ideal number. Less is obviously a lot easier for the respondent, but more gives you potentially more data to pick up on things. So it depends, and it'll also depend on things like how wordy your levels are and things like that. So if I have to throw out a number, it's 7, but recognize that that's not there's a big asterisk next to that, and there'd be a big footnote underneath that. All right, next one, monitoring sentiment in an omnidata kind of way to know the thoughts of your ideal product. That's interesting. There is actually a presentation. I can't remember. So Sawtooth Software, we'll plug our conference a little bit. We hold a conference every year where people come and present research, and it obviously has a preference modeling kind of slant, but it also includes things just about general survey research and things like that. There was a really interesting paper showing using a very basic conjoint for a brand tracker, so repeated measures over time, did a really, really nice job at mirroring overall market demand for things. So that's a really interesting paper. If you want to like send an email into support@sawtoothsoftware.com, we can find that paper and give it to you. All of our conference proceedings are free on our website. So Conjoint, there's good evidence that it does really well for tracking sentiment over time. I'm not sure if we've gotten much about combining Conjoint with social media listening or things like that. Probably would be a fantastic proposal for an upcoming conference if you wanted to think about that.
Yeah, good point on the conference, Brian. I just put a link to the conference in our chat coming up April 29th in San Antonio. We're excited about that.
Cool. All right, statistical power. So obviously this was a beginner webinar. We didn't talk too much about math and sample size testing and power analysis and things like that. We have tremendous resources on our website that do dive into those topics a little bit more. It's going to be another it depends one. A nice recommendation is 200 to 300 respondents is pretty good for a choice-based conjoint approach. One of the interesting things about those earlier 1970s linear approaches is that they do a pretty good job with really tiny sample sizes. That's something you're interested in. We've got some papers and we can walk through some examples with you. So generally, a couple hundred is good. But it depends on the method you're using. Some of them are quite good with very tiny sample sizes. So the optimal balance between attributes and levels. Yeah, so we've, again, lots of papers and research. We can direct you to some of those if you want to reach out. There's some evidence that the error introduced by fatigue kind of counteracts the benefit of asking additional questions for people. Again, when you get to that kind of 12 to 15 mark. So again, if you want a simple example, you want a simple number and I have to do something, 12, but it's got a big asterisk next to it. And it's going to depend on how motivated people are. You know, if they're a very technical person, and they want to see lots of technical details, then they're probably going to be fine with more attributes and levels. So it definitely depends, but I'll toss out 12 if we have to give a number. 12 choice tasks is a nice target. Okay. So someone asked, what's the relationship between attributes? Is price more influential for Mexican food rather than Thai? So we didn't get into that. That gets into a bit deeper discussion about modeling the data. There is a way that we can try to come up with those adjustments. We typically call them interaction effects, and they're essentially an additional number that changes the utility. So one example we use in our trainings is I have a type of car and I have a Toyota Corolla and then I have a Mazda Miata, a little two-person sporty car. For some reason baked into our brains, red means fast. And so red is a lot more desirable to pair with the Mazda Miata than it would be for the Toyota Corolla. So that type of a relationship, that interaction effect is something that you can look at in Conjoint in general. We don't yet have that capability in Discover to kind of tweak your model and do things like add interactions. We do that in Lighthouse Studio in our desktop platform. And it is something usually you want to consider and look at. If you have the capability, you can run different models and try to say, hey, adding this extra adjustment, this interaction, does that change things? Does that make me fit the data better or fit the data worse? And things like that. So that is definitely a part of the world of conjoint modeling. Someone asked for utilities, do we need to scale them? Yes, we absolutely do. If you want, we have another webinar that goes a bit more into all the depths of utility estimation. Again, if you want to write in, we're happy to direct you to that. We typically do a rescaling procedure because the magnitude of those utilities are different respondent to respondent. It's very similar to I use 1 to 5 on the scale, but Justin only uses 3 to 5. A 4 and a 3 don't necessarily mean the same things for us. So we do typically go through a rescaling procedure so that when we do things like calculate averages and things like that, it's a more fair comparison. For sure. Good question. Is conjoint a good method when working with B2B samples? Yeah, so I think we talk about this. Keith in our consulting team, I think, did a webinar. It's either a webinar or a paper. He does a lot of work in pharmaceutical studies with very, very limited sample sizes. You're looking at doctors that specialize in a particular thing that are willing to take a survey. So the methods do still work. One of the neat things, we didn't have time to talk about it, is that when you run these regression-based models, you get a fit statistic for each respondent that can indicate kind of how reliable, how consistent someone was being. And so you can build utilities with small sample sizes. You can build utility sets that fit the choices that people gave very well. But you're going to run into that what's the word I'm looking for? Like a projection problem, representative issue, right? If I only survey 10 people, I can build conjoint utilities off them, but obviously I'm going to have very large standard errors on the averages, and I'm going to be potentially hesitant to try to project that result into a much larger population. However, if 10 people is all I can get, I personally am going to prefer something like a conjoint model over asking that person rating scales, right? Or a ranking question or or something like that. So the methods can still work. They can still hold up. They don't blow up and everything's wrong with tiny sample sizes. And again, it depends. There's certain things we can do, different types of exercises we can ask that are a bit more appropriate for smaller sample sizes. That's a great question. Let's see. Where's the best place to go for more of the math behind how conjoint uses regression? So it kind of depends on the level that you're at. I don't know if we necessarily get into the basics of like what is a logistic regression. You're probably going to be better off looking into some kind of statistical sources for that. We do have really good documentation. We have some things that I mentioned. There is another webinar that dives a little more into depth about the different ways we can do utility estimation. We'd be happy to share you with that, share that with you. If you want to go a lot deeper, we've got technical papers that talk about that hierarchical Bayesian approach. It's almost like there's different levels. The best thing I would probably say is to write in and let us know kind of where you're at and what you're looking for, and we can probably direct you to the right level of information you're looking for. Let's see. We've got a question, when you would want to use choice-based conjoint versus best worst scaling case 3. Aaron, I'm probably going to ask you, is case 3 just doing a traditional choice-based conjoint, but asking the best and the worst on the concepts? Am I remembering my case three correctly? I actually don't know if you're set up for audio since you're just doing Q&A.
Can you hear me?
Yeah, hey.
Yeah, I'm gonna have to go back and look. You caught me off guard, and I need to.
Yeah, I
I,
can't.
I I will answer that question.
We definitely have the answer. I'm pretty sure best worst case two is the hybrid approach.
Yeah,
So
case
under
three, I think, is just asking best worst of the CVC task itself.
yeah. So
Our software allows you to do that.
let me get to so something like this, we would put two answers in here and say which one of these is the best, which one of these is the worst. Um, I know we've got papers about this from past proceedings and things. I can't remember exactly what they say. I want to lean towards the idea that it didn't do quite as much as the authors thought it would. It didn't necessarily improve things as much. So I don't think it's super popular. Lighthouse Studio, our desktop platform, does allow you to do best worst conjoint, choice-based conjoint tasks and adds both of those questions. I don't think it gets a lot of use. I don't think it's super popular. But we can definitely find some of that research for you and share it.
Yeah. So best worst scaling case three. I think you typically I tend to look at using it in situations where I'm not, I can't ask enough questions and I just need a little bit more data, but I can't really increase my sample size. I can't really increase the length of the questionnaire. And asking for the worst choice also gives me just a little bit more information. You do have to recognize though that when people give you their worst response, it's not necessarily using uh, the same logic that went into choosing their best response. So they're not necessarily mirror images of each other. In fact, often they can be very different processes where choosing the worst one is using risk avoidance thinking and choosing the best one is maximizing utility thinking, and they're just very different processes. So uh, be aware of that. A lot of times in practice, it doesn't make that much of a difference. They're close enough models that you can do that relatively easily, but there are some situations where people use totally different logic there. Um, so yeah, so those are the times when I use it is when I just need a little bit more information, and I don't think that people are using fundamentally different thinking to avoid bad products.
Mm-hmm. Yeah, there's definitely been some research, particularly with Max Diffit, looking into is it okay to be combining best and worst choices to build a single model? And I believe that research shows that, like Aaron said, yeah, you do get different numbers if you isolate them and you build a model of predicting bests and a model of predicting worsts. You get different numbers, and so it's I think it's worth thinking about. But we haven't seen probably not too much to worry about it a lot and like not do it kind of a thing. I was just going to look through here and see if there was anything interesting. Someone asked a question about segmenting, and I thought, oh yeah, I didn't go through and look at my segments here. The question is kind of interesting. When looking at differences within segments of the surveyed population, is it normal to see higher consistency as the sample size increases? I don't think I actually know the answer to that off the top of my head. Um, I I'm inclined to say I wouldn't think so because if as you get more respondents, if I'm all over the place, I don't think that's necessarily going to make my consistency score a little better. Um, I'll toss it out. Aaron, Cameron, I don't know if you guys have any opinions, if you've seen anything.
Um, Yeah, Matt, I'm not sure what the specific answer is. I think sometimes it depends on the situation. There has been some research done that's kind of interesting, looking at when you're looking at utility estimates for different size populations, how much consistency do you see? So if you create synthetic data and you've got one group that's a really big group that's got similar preferences and a smaller group that has similar preferences, are you able to recover those scores very well? So there is some research on that, but I'm not sure what the best answer is to your question.
Yeah. I think the last one we'll do is differences between MaxDiff and CBC. So again, we've got webinars and things on this. The short answer is that MaxDiff is typically treated like a one attribute conjoint. So we ask people for we take levels of things like ice cream flavors or benefit statements for a product or something like that. And rather than put them all together and build up like our Lego blocks, we're kind of looking at one block at a time and say, do you like the yellow block better or the red block? And we're just trying to come up with the same thing, utility. We're fitting choices, but we're doing it where we just have a list of items and all we really care about is the relative utility of those items. So MaxDiff is great when it's a great replacement when you would normally use things like rating scales and ranking questions. You might say, rate these ice cream flavors on a scale of 1 to 5. But if you have 20 ice cream flavors, that's going to be difficult. You're going to get a lot of ties from people. And so what MaxDiff does is it would show several of the ice cream flavors at a time and say which of these is best, which of these is worst. Conjoint is really when you want to build that additive model. We want to say Coke plus Diet Coke plus can plus price is some total product with some total utility and benefit to it. So they're very, very related in how they work, but they are kind of different starting points to what's the world am I in? Do I just have a list of things or do I really want to build that Lego block building up a product type of a thing?
Thank you, Brian. Interesting. We went over by 15 minutes, but we still have tons of people that hung on to the bitter end. So that's a good sign that people are very interested. We had so many questions, like so many. And so we were excited to have you guys participate. Brian, you did an excellent job. And thanks to Aaron and Cameron for jumping in at the end and helping out with all these questions. With that, we'll see you next time. We'll answer up these last few, but appreciate everybody for coming. Come back. We'll continue to do these awesome webinars. Talk to you later.